NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, and more beautiful than humanity's dreams. The largest telescope ever flown launched into deep space on Christmas Day 2021. Its primary mission is to reveal the "let there be light" moment when the stars and galaxies first ignited after the Big Bang. Recently, we got a look at some captivating images as Webb peers back toward the origin of everything. The story will continue in a moment. This is one of Webb's early deep dives into the cosmos. 250 hours of exposures that expand the imagination. All these little dots are stars, and all these little dancers are galaxies, some of which are bigger than our own. Astrophysicist Brant Robertson flew us through 130,000 galaxies, half never seen before, enormous swirls of billions of stars each, some like our own Milky Way, and others well out of this world. We call this galaxy at the center of the screen the cosmic rose, just by chance, because it looks like a rose. You can see that dusty red irregular galaxy. Space is more crowded than you might think, and actually, galaxies wind up interacting with each other. They will merge together. So, I'm zooming in now on a pair of galaxies that are merging together, interacting. You can see that they're disturbed because the gravity of one galaxy yanks the stars out of the other galaxy. They're running into each other. Robertson, of the University of California, Santa Cruz, helps lead Webb's most ambitious mission, the Advanced Deep Extragalactic Survey. We've discovered the most distant galaxy in the universe, the one that is the furthest away from us that we currently know about. I'd like to share that with you. Can I show you some pictures? As we zoom in, we keep going, and now this red splotch that you see there, that galaxy, is more than 33 billion light years away. How long after the Big Bang, the beginning of the universe, did this galaxy form? It's amazing. It's only 320 million years after the Big Bang. The most distant galaxy so far, there on the right, doesn't look like much, but astronomers can fill textbooks by analyzing the spectrum of its light. We can actually measure things like how fast it's forming stars, the amount of stars in the galaxy, the size because we know how far away it is, and the typical age of the stars in the galaxy. So, we know a lot. The earliest galaxies so far formed when the universe was 2% of its current age, and the baby galaxy ignited stars at a furious pace. It's like a hummingbird. The heartbeat of this galaxy is so rapid. What do you mean by that? Well, this galaxy is forming stars at about the rate of the Milky Way, even though it's 100 times less massive. So, it really is like a hummingbird. The heartbeat of this galaxy is racing. T-minus 30 seconds and counting. More than a few human hearts were racing in 2021 as the $10 billion observatory readied for launch. Earlier that year, we were among the last to see Webb in California before it was folded into a 15-foot wide nose cone. Well, somehow that's a lot bigger than I imagined. 25 years in the making, Webb is named for an early NASA administrator. Northrop Grumman engineer Amy Lowe showed us down below the silver-colored sunshield, as big as a tennis court, and 21 feet of gold-plated mirrors for gathering light. There were 18 of these hexagonal mirrors, but when you fold them out, they all work in concert as one mirror. That's right, all 18 images will form one very nice, solid image. Liftoff, from a tropical rainforest to the edge of time itself, James Webb begins a voyage back to the birth of the universe. Webb lofted on a European rocket into an orbit around the sun 1,000,000 miles away, set up for observations. Engineers used a star to align those mirrors, but the image was speckled with what looked like artifacts of digital noise, which forced a closer look. These were not artifacts from the detector. These were not strange stars. The whole of the sky was filled with galaxies. There was no empty sky. And that's when I went, this telescope's going to be phenomenal. Matt Mountain leads Webb's operations as president of the Association of Universities for Research in Astronomy. No empty sky? What do you mean by that? Almost every image we're taking now, we see galaxies everywhere. I mean, we took a simple picture of a planet in our own system, Neptune. You know, it was this beautiful orb just sitting there, and we saw some rings in the background, and galaxies again. It tells us that the universe is filled with galaxies. We knew this theoretically, but when you go out to the night sky, we're used to saying, well, look up the night sky. We see those stars. We can no longer say that. We now have to say, look up the night sky, and there are galaxies everywhere. We call it space because we thought there was nothing out there. There is no empty sky with James Webb. That is what we have discovered. Matt Mountain says that Webb is a reminder of how much we do not know. For example, galaxies are rushing away from each other at greater and greater speed, defying gravity. It makes no sense, so scientists infer that there must be unseen elements at work. They call them dark energy and dark matter. And whenever you hear the term dark energy or dark matter, this means we don't know what it is. We're not that imaginative, but it is a force. It is 95% of our universe, and we have no idea. What it is? Wait a minute. 95% of our universe is made up of dark energy and dark matter, and we don't know what it is. Correct. We're lucky if we even understand 4% of our universe today. Astronomy is a very humbling discipline. Laughter. Humbling, but with Webb, look at this. Also thrilling, look at this. Right. This is Purdue University astronomer Dan Milisavljevic, starstruck and chatting with a colleague. Yes, the detail. Even Wilbur, who's not an astronomer, strained to see what the excitement was about. Milisavljevic studies exploded stars, which were the furnaces that forged the first heavy elements from a cosmos of simple helium and hydrogen. Every time there's a supernova explosion, it's producing the raw materials for life. The iron in our blood, the calcium in our bones, the oxygen that we breathe. Love that oxygen, all that is being manufactured in supernova explosions. The late astronomer Carl Sagan used to say, "We're all made of star stuff." That's exactly right. Webb reveals unprecedented detail at the center of these explosions, and that's what Webb is most sensitive to for our purposes. Understanding what's happening inside the explosion that we couldn't see before, because it only comes out in infrared light. Infrared light is what Webb is designed to see. Like a night vision camera, the telescope is sensitive to heat radiation, which is all that remains of the light reaching us from the dawn of time. Trouble is, infrared is invisible to the human eye. When you first pull up the Webb data, what does that look like? Essentially, it looks like a blank screen. Alyssa Pagan and Joe DePasquale are astronomers and science imagers for the Space Telescope Science Institute. This is what a Webb infrared picture looks like until they match the data-filled darkness to colors of wonder. So, we take those longest wavelengths of infrared light and give those the red colors. The next shortest wavelengths would be green, and then the shortest wavelengths that we get from Webb are colored blue. And so, just like how our eyes work, we take those three color channels, combine them together to create the full color images that we see from Webb. Among their favorite images is this cluster of stars with the not-so-wondrous name NGC 346, cosmic dust sculpted into ripples by interactions between stars, and the Tarantula Nebula, a star-birthing nursery on a backdrop of galaxies. It occurs to me you're the first two people to see these images in human history. Yeah, it's quite an honor. It is a great honor, and it does blow your mind every time. There will be many mind-blowing revelations. Webb is already the first to find carbon dioxide in the sky of a planet 700 light-years away. It will continue to look for planets with atmospheres that might support life. On the other end of the time scale, astrophysicist Erica Nelson of the University of Colorado Boulder thinks her team may have made a discovery that she says would break the theory of how the early universe formed. Either this is wrong, or this is a huge discovery, and we think that it's a huge discovery. More observations are needed, but Nelson is investigating what may be 5 giant galaxies that appear to have formed much too quickly after the Big Bang. If they're confirmed, astronomy may have to revise the timeline of galaxy formation. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe. Brant Robertson, who showed us the earliest galaxy found so far by the James Webb Telescope, told us the record for the earliest will not hold long. How far back can you go to the origins of the universe? Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful. Will the history of astronomy be divided between before Webb and after Webb? Yes, I believe it will be. Matt, who manages Webb operations, told us the observatory may last up to 25 years, perhaps long enough to comprehend space and time and the origins of life. We're seeing a universe we've never seen before. We thought it was there. We hoped it was there. But now we see it for the first time.